Hello, welcome to our first video about polar coordinates. Today we're going to talk about polar coordinate basics, which basically consists of plotting points and plotting basic graphs. So first, the coordinate system, the polar coordinate system, the origin is around a fixed point called a pole, and kind of like your North Pole and your South Pole, and your longitudes and latitudes, you're actually kind of making circles to represent your cross sections instead of in the XY coordinate plane, sometimes called the rectangular coordinate plane. You have an X and you have a Y, and that gives you a point somewhere. Okay. This time, you are going to be given an R, which stands for radius. So that indicates the ring that you're on. Sometimes people call it a ring. 1, 2, 3, 4, counting from the center. And then a theta. So this is just an angle of rotation. This angle could be measured positive or negative. Typically, if it's a positive angle, it's going to rotate counterclockwise. And this angle could be measured in degrees or radians. It just depends on the situation and what you're given. So, typically in the rectangular coordinate plane, your most important axis, your starting point, or your most popular axis is your positive x-axis. So it's kind of the same here. You have hidden within here like your x and your y-axis. So this is where we start, typically. This is where we'll count our ring, and then we'll rotate our particular degree measures. So I have some points that we're going to plot. Notice they're all 3 and they're all 60. It's just a variety of different combinations to kind of see how each point plots. So first, 3 indicates the ring. So 1, 2, 3. We're going to be on the third ring. So the third ring and then 60 degrees. So 60 degrees rotates here. So this would be my point. But technically this little arc that I drew isn't really in it. It's just the point itself. So on the third ring, 60 degrees from that ring, from the starting axis. Okay. And then I have the point 3, negative 60. So this time I'm starting on the third ring again, but this time I'm going negative 60 degrees instead of positive. So you want to pay attention to the numbers on the axis here, because these are all labeled as if you're going counterclockwise. Well, now, since we're going negative 60, we're going clockwise. And so negative 60 would be the same as going 300 degrees counterclockwise. So that puts me right there. Now, this does bring up an interesting point. In the XY coordinate plane, you have unique points. Every X and every Y gives you one specific point. In the polar coordinate plane, there are several points that actually have the same, or several points that have different numbers but actually are the same point. So, for example, the point 3, negative 60 is the same as the point 3 and 300. It just depends on which way you rotate. So now let's deal with some more negatives. If I have the point negative 360, now usually I'm starting here, 1, 2, 3. I'm still starting on the third ring, but I'm starting from a different perspective. So instead of starting on what is technically the positive x-axis, I'm actually going to start on the negative x-axis. So I'm going to go over here, 1, 2, 3. So still on the third ring, but this time I'm just starting on it from the opposite side of the coordinate plane. And then I'm going positive 60. So again, I'm rotating counterclockwise. So I'm actually rotating down. So 60 degrees from this 180 degrees would put me at 240. So I'm right there. So negative 3, positive 60. Because again, you're going counterclockwise. And then the next one, negative 3, negative 60, it almost seems counterintuitive, but you start here and you actually go up. You're going 60 degrees back from 180. So that would be at 120. And again, there are lots of equivalent points here. Like if we were rotating forward, this would be equal to positive 3 and 120. Or you could say that this is equal to positive 3 and 240. There's lots of different ways that you can come up with equivalent points. And a lot of times it really just helps to draw them. And we just talked about that. So we will skip that and let's do here. Name a point that is in the same position as negative 2 and then pi over 3. Now, again, we are measuring in radians this time, which is a little scary. If you don't like radians, remember when you convert from degrees to radians, you would just multiply by 180 and divide by pi if you want to change the radians to a degree, which is totally allowed to do. If you don't like it, go ahead. So this is the point, negative 2, and then the pi's would cancel. And 180 divided by 3 is 60. So negative 260 degrees. So there are lots of different things that I could do. And I'm just going to make a rough sketch of this just because I like a visual. So I'm going to be on the second ring. So let's see, here's my first ring. And so this would be my second ring. It's nice if you have grid paper when you draw this, because you can kind of try to make your rings a little symmetrical. So I'm going to be on my second ring, and I'm going to rotate 60 degrees, which almost seems strange. I'm going to be on my second ring on the negative end this time, because I'm going down, and I'm just going to do an estimate. I'm going to say I'm about right here for 60 degrees. So one thing that you could do is you could just add 180 onto 60. Now this would no longer be negative 2. This would be a positive 2 at this point. So 180 plus 60 is 240, and we actually already talked about that. But let's kind of stick with the radians for a minute. So remember that 180 is just pi. So you could take pi, you could make this positive, and then take pi and add on 3 pi over 3. Remembering that you would need common denominators. Let's write that in a different color. When you add those two. So 3 pi over 3 plus pi over 3 would be 4 pi over 3. There's a couple different other ways you could do it as well. So you could say that maybe you start here on the positive 2 again, and you want to rotate that way to get to that point. Again, a lot of different ways that you could do it, but you need to realize that you're not going a full 180 this direction. You're going a little bit less than 180. So this would be 3 pi over 3 minus pi over 3, which would end up being 2 pi over 3. And again, be aware you rotated this way. So that would be negative 2 pi over 3. If you wanted to get really fancy, there's another way. There's even another way you could do it. You could say that you rotate around the circle like 3 times and then land on your point. Or you could keep it negative. You could stick with the negative. And instead of rotating, let's erase some of these arrows so it makes more sense. So if you were starting on the negative 2, you rotate it all the way around this way. That's another way of saying it. Meaning that you almost go a full circle, but not quite. So that's like saying 2 pi minus pi over 3. Almost a full circle. Remember, 360 degrees is 2 pi. And again, common denominators are your best friend. 6 over 3. This is negative 2, and this would be 5 pi over 3. And again, I made that negative 5 pi over 3 because I'm rotating clockwise that time. So there's lots of different ways to represent these points. Now let's talk about graphs of polar equations. And there's 2 main graphs that I want you to be able to recognize right now. One, this first one, just says the radius is 3. Which means that I don't really have a specific angle I'm looking for. I just want the radius of this circle to be 3. I want the set of all points that have a radius of 3. So all you do is go to your third ring, 1, 2, 3, and draw your third ring. This is just a circle. So I could give you r equals 10 or 15 or 20. As long as it's just a plain r equals, it's going to be a circle. And then the other one I want you to be aware of is if you have a lonely angle, this is saying I want every single angle that is at negative pi over 6. Negative 30 degrees, for those of you who prefer degrees. Every single angle that measures negative pi over 6. So first, just find it. So you know you're going to rotate. There's 0. There's your positive x-axis. You're rotating this time backwards. You're going this way on my 330 line. So any single point that lies on 330 satisfies this condition. All angles that are negative pi over 6. But remember, just like what we did up here with the points, you can also rotate negatively. And start on the negative axis instead of the positive axis. So you do have your negative pi over 6 or your negative 30 this way. So it's actually this full line here. Those would be all of the negative pi over 6s. It's basically saying the radius can be whatever it wants. I just want every single angle to measure negative pi over 6. And that's all I have for our first video about polar coordinates. Feel free to rewind, email me if you have questions, and as always, make good choices.